Hello, good morning. My name is Steve Coast, and I started OpenStreetMap, as Ryan said, about a decade ago. It was August 2004, so we're just coming up on the party. The idea behind the project was very simple, if a little bit audacious, to make a map of the world with volunteer contributions and then give it away for free. When the project started in 2004, Wikipedia was this hot new thing that was doing the same thing with text articles. And so I figured, why not do the same thing with maps? As we'll get into, in the beginning, there was no data at all. There was nothing. And all we had, I mean, this is before the iPhone. There was such a time. We had very poor, expensive GPS units to collect data. Similar data to what you see on the wall, but much thinner. And volunteers going around. We didn't even have satellite imagery, which is another thing you'll see pretty soon. Today, you can just draw on top of a picture where the roads and the buildings are. That wasn't available back then. And over time, the project has exploded to where it is today, which is consumer-facing turn-by-turn navigation, which is kind of important. It's really making OpenStreetMap available to everybody. OpenStreetMap, unlike Wikipedia, has been a bit of a hacker project for a very, very long time. And now it's consumer-facing, which is really the end goal, or it's at least my end goal. The project is a very large community of people with different visions. So I thought I'd start by talking about this report that just came out. It was leaked from the New York Times. It was their newsroom report on innovation, and it's worth a read. It's quite fun. The basic issue behind the report is, what do you do with all of these competitors who are competing with the New York Times? They have a nice little quote in there that Flipboard actually gets more readership out of New York Times articles than New York Times does, which is pretty impressive. I was reading through this thing on the plane, and they had this really nice graph that I noticed to discuss exactly what innovation is, right, that I thought would be a nice launching point. And they have these three things that I'll go through. The bottom axis here is time going on to the right, and up is quality. And the line up here is supposed to represent essentially the New York Times or any other newspaper. So over time, they improve in quality. They add features. They add a website, whatever those kinds of things are. But the customer only needs some level of quality, right? And something comes up from underneath, which they term a disruptive innovation, which meets the same quality bar at a lower price, effectively. And what happens is one of them doesn't win. And that's what the worry is for the New York Times, is how do they deal in this world where print is under attack. So we can do the same thing with mapping, almost exactly the same thing, right? Closed maps have been going for a very long time. The quality continues to get better. They do indoor mapping. They add more and more roads, turn restrictions, whatever it happens to be. And what we've had underneath is OpenStreetMap effectively coming up with the same trajectory, just a later starting point, but community contributed, so it's a lot cheaper. So as this thing keeps going, and what you're seeing today is that tipping point, right? Where we're now meeting the minimum quality for consumer turn-by-turn navigation. This is what I believe is happening, right? These things are going down. Of course, you know, this is a very simplified model. What tends to happen is people innovate and they go do new and interesting things. But this is one of those turning points. When the project started, this was one of our first sets of data. This is very similar to the data that you see on the wall, except it's animated. You're looking at 3 different days of people driving around London in England. This was a courier company who were very early on in putting GPS devices on all of their motorcycles as they're delivering packages between typically financial institutions in London. And it was started by a couple of guys who tried to send some tickets across town, and the tickets got lost. And they're asking, why are we, you know, it's 2005, I think this was, or 2006. Why are we in a world where tickets are still getting lost when we have GPS and mobile phones? Again, this was pre-iPhone. So I'll describe a day. Each of these days here gets a marker. So this is the morning. They start driving around. And then there's a break for lunch, that little pause. They keep driving around. And then they go home or they go to the pub. And then around midnight, they go home from the pub. Right? So this data tells a story, this activity of both where people are going, when they're going, and you can find out pretty easily what it is they're doing. If you aggregate all of this data together, what you get is something that starts to look like a map. So this is London again. There's another print of London up there on the wall. And this is old data. These red lines are from one day and the blue lines are from another. You can see things like this is the River Thames, this is Hyde Park, Regent's Park. The thickness of each line is because when many people go down a road, each GPS has a different error offset, and if lots of people add all those errors on top of each other, you get thicker lines. So the lines you see in these prints, they're not the classification of road, it's just lots of people go down those individual roads. So the idea is you could draw on top of that, right? You could take these traces and you can say that's Regent's Park, this is Baker Street, whatever it happens to be, and then share out that data. That was the idea. OpenStreetMap exists for sort of 3 reasons. Maps aren't free, so they're not zero price, and it'd be really nice if they were. When I started the project, the map data that was available to me as a student in London was extremely expensive. That was one of the other motivators. They're not open, so even when you pay for map data, you're typically very, very restricted in what you can do with it. And they're not current. Every map has issues, right? And most of the maps have a lot of barriers between you and fixing them. Wikis are the obvious next step, especially back in 2004. Wikipedia was taking off, it approved the model, so the idea is how do we do the same thing with maps, right? How do we put this into a model where anybody can edit it? And it's just fun, as I hope you'll discover. There were some quotes back then also that I found important. There's going to be 3 of them, they're pretty quick. The first one says, it's absolutely possible for a bunch of smart guys with the technology we have today to capture street networks and potentially the major roads of the UK and minor roads. That was Ed Parsons, who now works at Google and used to work at the Ordnance Survey. The Ordnance Survey in England was another motivator for the project. It's a British government agency, a bit like the USGS, except better funded. And they're paid for by the taxpayer. They make a really very good map of Great Britain, and then they essentially keep it to themselves, and then they sell it in the private sector. We have these quasi-public-private institutions in the UK. Ed jumped ship from OS to Google, and that pointed to it. The second one, if you don't make lower resolution mapping data publicly available, there will be people with their cars and GPS devices driving around with their laptops. They will be cataloging every lane and enjoying it, driving 4x4s behind your farm at the dead of night. There will, if necessary, be a grassroots remapping. That was Tim Berners-Lee who invented HTML and HTTP. He's absolutely right. We've had people arrested for doing this kind of thing in OpenStreetMap. The best place to get a GPS trace in OpenStreetMap is right down the middle of the road. And the only time to walk down the middle of the road is when there's no traffic, which would mean 4 o'clock in the morning. And so, yeah, people have been arrested for walking down the middle of the road with GPS devices at 4 o'clock in the morning for the greater good. The last one, you could have a community capability where you took the GPS data of people driving around and started to see, oh, there's a new road that we don't have, a new route. And so that data eventually should just come from the community with the right software infrastructure. And that was Bill Gates. And all 3 of those quotes came in 2006, 2 years after OpenStreetMap was founded. But what we really do in one sense is we make beautiful maps which are just then open to everybody. So when you start with OpenStreetMap, it looks like this. Everything here is open and free, the country boundaries, the boundary between the sea and land, which is slightly different, the names of everything. All of this is rendered using open source software, and all of this was community contributed or imported from one of a couple of public data sets, which I'll describe. As you zoom in, more stuff pops up. So you start to see freeways. It looks just very similar in structure to many other maps, except it's open and free and so on. National parks, land uses, cities, hydrology, everything in here has been contributed by somebody volunteering in one shape or form. We're going to zoom right into where we are. I want to point out parks. So a big strength of OpenStreetMap is all these footpaths and cycle paths. In Golden Gate Park, the Presidio and so on. All of these buildings were community contributed and imported. Here's some of those one-way streets that are very important because as a Scout user, we don't want to route you the wrong way down those things. Right down up until the hotel here. The editing experience is very simple. So you look at the map, and in the same way you look at Wikipedia and you might be reading an article and you click edit, in OpenStreetMap it's the same. So you look in the area and you click edit, and then this pops up. This is the ID editor showing where we are right now. The satellite imagery is donated by Microsoft, and then on top of that you see OpenStreetMap data, and then there's a bunch of tools to edit it. The editing experience is not as simple as editing text, which is someone that everyone with a computer does every day. You have to spend a little bit of time, which we'll do this afternoon, learning how to do that. But it's pretty simple. So you click on things. This is a hotel. It's the Hotel Vitale. This is the address and so on. You can go in and fix those things. then you can just hit the big save button, which lights up once you've made a change, and then it's available to everybody. The data in the beginning in the United States came from something called TIGER, which is a public domain data set put out by the Census Bureau. One of the missions of census is to know where you are, as well as attributes about you. And in order to know where you are, they need a map, right? So they built a map which was, at the time, topological. So it looked like this. This is Oakland, there's Lake Merritt. And this is what TIGER looks like when we imported it. So if you imagine the United States had no mapping data at all, and then we imported this public domain data set, this is what it looks like. It's spatially not very accurate, so it's supposed to be a gridded city, but you can see everything slightly out of whack. You can see that the on-ramps aren't digitized very well, they're just very simple lines. But it's functional and it's better than no data at all. If you skip forward about a year, this is what the data looks like. And this is just with people editing it themselves in their spare time. So they're adding things like the classification of the road, the one-way streets, adding a few buildings, things like that. And then we can skip forward to how it looks today, which is much, much more detailed. And the same thing repeated across the world, right, and across the United States. Germany, for example, this is what it looked like in 2006, pretty blank. When the project started, people would map both things that were very near to them, but also the major features first. And so the major features might be the freeways or the autobahns in this case. And so skip to 2007, pretty much the autobahn network was complete, plus secondary roads. 2008, and then you can skip forward to, I meant to show this, also the level of detail when you zoom in also goes up, right? So once people do the freeways, the primary roads, the secondary roads, the normal roads, then you start adding every footpath. Some places people are adding every single tree, and I'm not joking, including the age of the tree, the type of the tree, those kinds of things. And the great thing is when you step up order of magnitude in the detail of the map, you're also stepping up the amount of effort required to both put it in and also to keep it up to date, right? Because trees change. So let me go on a little sort of world tour for a minute here. This is New York. All these screenshots are current and off of OpenStreetMap. You can browse around yourself. The other half, the south of the equator is also represented. This is Sydney, Berlin. Berlin is insanely detailed to the point where the zoo is mapped out very completely. So I like to joke that most maps will route you to the gate of the zoo. With OpenStreetMap, you can route to the nearest monkey or penguin or whatever you want it to be, because they're all tagged, as you can see. Zoos are a great use case of where OpenStreetMap wins. And by the way, these little green dots that you see, those are those individual trees being mapped, right? Now this becomes a challenge. Madrid, Spain, Amsterdam. People are making, by the way, people are making air maps now. The airport off to the side, all of that is functionally accurate if you happen to be a pilot. And there's also OpenStreetMap where people are mapping all of the buoys. OpenStreetMap has a number of sub-projects for people interested in specific data sets where they still use OSM as a repository for the data, but in order to get it out, they might have some other website which highlights the feature that's important to them. Copenhagen. It's difficult to remember all of these places. Baghdad. So we have Arabic script that works all around the world is what I'm trying to get to, Kinshasa and so on. The level of detail, the comparisons that you'll see just yourself looking around are quite insane. This is one of my favorite and early comparisons was just footpath data in Stanford, right? Because people, when you're getting around Stanford, you typically you want to walk, you don't want to drive, right? There's different use cases beyond just driving. We had maps even for people like Flickr back then. So Flickr wanted to show, in the beginning when Flickr was getting started with mapping and they realized they could put photos on a map, they didn't have any map availability in places like China, whereas OpenStreetMap, despite having bad data, and I want to actually highlight that, the quality of the data has improved dramatically over time. This map is actually pretty poor, but it's better than nothing at all. And that's an important point for the mapping industry, who tends to think in terms of 100% complete great data or nothing at all, whereas OSM is always something is better than nothing, if that makes sense. Here's another great use of OSM. This was, I'm going to forget the name of the bridge, but it was washed out after Hurricane Katrina, and the aid trucks were still being routed over those bridges. I think, in fact, the Red Cross was still sending trucks over that bridge because they thought it was still there. And people on the ground told them to stop routing over it, but they thought it was still there because it was still there on Google Maps and Yahoo at the time. Whereas in OpenStreetMap, it was pretty much taken off instantly and marked as destroyed. And then I think it took 3 years to rebuild that bridge, and then it was straight back on OpenStreetMap. But it took a further 6 months for it to get onto Yahoo and Google again, because they have to send out people to check these things. So that's important if you're on the ground and using that map, right? The project, as Ryan mentioned, has been growing exponentially since the beginning. The great thing about exponential curves like this is that they're scale-free, so it always looks like an exponential curve, whatever time series you pick. This is current. We're actually just over 1.6 million up here somewhere, and this is registered accounts. We'll go into a breakdown of what that looks like shortly. But let me show you what the project looks like as it's growing. So this is 2008. The reason it's 2008 is there are too many edits now to make a video like this and still make it coherent, because there's so many people editing. We're starting in a town in England called Ipswich, and then each of these flashes, that's someone editing something. There's a time series at the bottom left going January, February, March, and so on that goes through the year, and it's going to loop through the year several times. You can see the density in Germany and England. There's lots of people mapping in those places, as opposed to others, because it's where the project started. Here's the US. That's the Tiger import, that data I showed you earlier being imported. I think as we come around this time, you'll see India. So India was the data set donated to us by A&D, which is another mapping company based in Europe. It kind of gives an idea of the scale. Some of those flashes you've seen were also bots. So in the same way that Wikipedia has bots going through articles, double checking spelling, things like that. OpenStreetMap also has bots going through, making sure roads are connected, making sure there isn't profanity in the map, all those kinds of things, and they're making little edits all over the place all the time also. So let's talk about using OpenStreetMap as an editor. Use a GPS device. Your device might look like this or like this. This is the kind of thing we used to have to use before there were phones with GPS devices. And then you get that trace and you edit it using these simple web-based tools. So if you're just getting started, you might use ID. This is the same thing that I showed you earlier. So you click edit, and then this comes up in your web browser. Any modern web browser will run it. And if you're more of a hardcore mapper, you might use a specialized tool. This one is called JOSM, which looks like a GIS. It's an open source OpenStreetMap editor. It stands for Java OpenStreetMap Editor. And it can do a lot more than what you can do on the web. So for example, a lot of people take a bunch of photos when they're editing. So what you're seeing here are some GPS traces. There's those little small yellow dots, and then you're seeing vector data on top of that, and then you're seeing photos. You take photos to remind you about the things that you're out mapping. If you're starting with a blank slate and you don't know the names of the roads, after about 5 or 10 roads, you can't remember the road names anymore, therefore you take photos. Road names are just one part of it, of course. You might be mapping points of interest, you might be mapping house numbers, whatever it happens to be. And then you can export that data. You can put it on devices like this. So your typical hiking GPS, you can just put it on an SD card and go use that when you're out and about. You can use it on an iPad. This is another rendering of OpenStreetMap data in Dublin. And then it's used all over the web by all kinds of different people. So Craigslist would be an example. Craigslist uses OpenStreetMap to display where things are, both in these aggregate views that you can see by going to Craigslist and clicking on map, but also when you're looking at a specific listing on Craigslist, you can also view, as long as the person's added it, where things are. OpenStreetMap was used by the White House. So the White House was on OpenStreetMap, and OpenStreetMap was on the White House, which is quite nice. And it's used everywhere, but most of those things have been display map, right? So it's good for Craigslist to be able to use OpenStreetMap when they're just putting listings on top of the map, but what we're doing is much more that routing piece, right? So let's talk about mapping parties. They're another thing that started a while ago. They tend to look a little bit like this. There's lots of people looking down confused at their GPS device, trying to figure out how it works. They started in the Isle of Wight, which is a little island just south of the UK. The Isle of Wight is about 30 miles across by 15 north to south. And the idea I had, this is 2006-ish, was why don't we get a group of people together to try and map the island in a weekend, right? So we had about 30 or 40 people, and this is the data we had before we went. This data is in the public domain. So in the UK, this expires after 50 years, is my memory. So this map was 1944, I think. And this was all that was available to us in the public domain to get started with. It was either a blank slate or it was this. And there's lots wrong with this because the map was 50 years old. So there's roads that have been built. Most of the train lines you see are those black lines. They've all been demolished. But it's better than nothing. And we can at least get the town names from it. We can get the outline of the Isle of Wight, those kinds of things. This is what we had after one day. So each color represents a different GPS trace. You even see the ferry trails, the people that took the ferries off of the island. There's 3 of them, left, middle, and right. And people, it was very experimental because it was the first one, but we sort of subdivided. So we all met at a community center in the morning. We divided people by what type of things they wanted to map, because some people want to drive around the cars and do all the lanes in between towns, those kinds of things. Some people wanted to walk around downtown areas, and some people wanted to bike around, right? And biking is a very efficient way of mapping lots of Europe, because lots of Europe is designed to be biked. People fanned out, collected their data. So they took those GPS traces. They took photos of where they were going. They might have a pen and paper taking notes like that. And then we came back, and you would edit that stuff into the map. And over a weekend, we essentially built a map of the Isle of Wight, which was a proving ground for both OpenStreetMap and for the idea of doing mapping parties. And people have mapping parties all over the world every month now. But it was good to get the Isle of Wight done, even if it was only 30 miles by 15. But one of the cool things about the Isle of Wight is it's an island, so you know if you're done or not, right? Whereas if we tried to map London, you never know if you're finished, right? But you know you're finished because if your feet are wet, you're not on the island anymore, right? So we mapped it. Now, not every single thing, every single turn restriction was not there, every single footpath and so on, but it was good for most purposes, right? It was good for people to start putting things on top of and to start using. This is another example of a mapping party where this bypassed the thing going around the green road going sort of clockwise around. That was actually under construction, and they had a mapping party there, and people just biked down it anyway and added the road, right? Because they wanted to get arrested. I don't know. There's been a lot of fallout from what we've been doing. So because we're mapping everything exhaustively, what you can do that is okay under copyright law is to take your map and then look at someone else's, and if there's changes, go out into the world and go and double check yours, right? You can't just wholesale copy from someone's map, but you can use it to check and then go out and recheck. And OpenStreetMappers have been doing that, and as you do that, you find these copyright Easter eggs, or trap streets is what cartographers call them. So what mapping companies do to protect their intellectual property is that they put mistakes in the map on purpose. This is what you should know. So this is a pun, lie close. The reason it's called lie close is because it doesn't exist. It's a lie. It goes through the middle of those buildings. So you know, the takeaway from this is not only are proprietary maps expensive, not only are they not up to date, not only are they difficultly licensed, so you can't do very much with them, it's also bad data on purpose, right, in case you copy it. And we've been finding all of those and cataloging them. We actually, a bunch of people found lots of errors in Google, and then Google started using the list to remove their errors in there. It was very entertaining. And the A to Z in the UK, that's the particular company with this one. So the idea is to put something on the map to protect copyright, he says. We try to put it in an area or a part of the road which would not be misleading to the ordinary person on the street. They have been put in out-of-the-way places. The only issue is that we all live in an out-of-the-way place, right? Everyone has somewhere that they live and might be out of the way to the other 99% of the population, right? But we've been finding those things. OpenStreetMap, these numbers are quite old, but they hold. Back when OpenStreetMap had 127,000 users, we did a bunch of analysis to figure out how many people are editing. And the upshot of this slide is essentially it's just like Wikipedia. It's a long tail. So you have some people who sit mapping all day long. That's a small group of people. And then you have a much larger group of people who might map once a month or once a week, that kind of thing. The breakdown basically comes down to Pareto principles. So it's 80-20 roughly. You know, 70% of people create a count and don't really map, and then the rest gets divided down into those top editors. So a small percentage of people actually edit on an ongoing basis. This is only a 2-week sample, but it's also a changing sample of people that are editing, right? And it's just the same as Wikipedia. Most people are reading Wikipedia, right? Most people are using OpenStreetMap. And that's a good thing, because when you find an error, you go fix it. And so the smaller number of people editing is an indication of people finding fewer and fewer errors over time, which is another thing. We have this virtual cycle in OpenStreetMap. So we have mappers out there. They run mapping parties. They meet up at the pub. They talk about mapping, things like that. And they go out and collect geodata, which turns into use cases. So once you've built a map, people start using it, right? And once they're using it, now there's more reason to contribute back to the project in this sort of virtuous cycle that is creating not just data, but it's also creating a community of people around it who are making it all work, right, globally, including the mappers out there, but also the people writing the software and making the servers work. And those loops are very interesting and remind me of this guy. This is John Boyd, who was a US Air Force pilot, who also did an awful lot of work on strategy. He was the architect of the 91 Gulf invasion, for example. He designed this thing a long time ago, which is the OODA loop. This is taught to all US Marines. And it stands for observe, orient, decide, and act. And the idea is you're flying along in your fighter plane and you see an enemy fighter plane. You observe it, right? You orient yourself based on a bunch of knowledge. So you figure out whether it's an enemy or a friend, right? You decide what to do. I'm going to shoot it down. You act. You pull the trigger. Boyd's theory was the more quickly you could execute this loop, the better chances you had of winning in whatever it was. Merely by being quicker, even if you're making mistakes, that was the point. Would you win? Certain to win was actually his phrase. And it's very similar to what we do in OpenStreetMap. What we do is we go and observe a change. So you might be walking along and you notice that the name of a road has changed, or a road is closed, or someone's built a new park, something like that. You go map it. So you need to collect some data. And that might mean some GPS traces. It might mean some photos of what you're mapping, right? Then you upload that to OpenStreetMap, and then OpenStreetMap goes, checks a bunch of things, and then it renders it into a map, right? And then you go back to the beginning. That loop is continuous because everything is changing in the world all the time. OpenStreetMap has a very tight loop for this, right? So a typical proprietary mapping supplier, that loop is measured 6 months to a year to 2 years, right? Because there's this hindrance of having to send out paid professionals to go and check something. So if you find an error in a proprietary map, they will send someone out to double check that that error is actually there, get it uploaded into their data set, send out a quarterly update, and get it back into the hands of the consumer. With OpenStreetMap, that loop is literally measured in minutes, right? So you can go fix stuff straight away should you wish to. And so what I'm positing here is that merely because OpenStreetMap is executing this loop so much quicker, just like Wikipedia, it's better than its competition, right? Even with relying on volunteers all over the world, and some people mapping lots, some people not, merely by that loop being quick are we winning. Closest penguin. So let's talk about the economics of OpenStreetMap. Yochai Benkler is an economist who wrote a bunch of interesting papers about commons-based peer production, which is what OpenStreetMap is. So when you think commons-based peer production, you should think something like Wikipedia or Linux, right? So it's a commons, everyone is contributing into it. It's peer-based because everybody has the same rights to edit, the same rights to fix things, the same rights to get stuff out, and they're producing a work. And this is in contrast to how you might traditionally build something like an encyclopedia, which would be the firm, right? You make a company to go do it. He says that for commons-based peer production to succeed, and he posits that commons-based peer production is more efficient than the market or the firm, which is the two traditional ways you go analyze this stuff. You need non-monetary motivation, so people have to want to do this stuff for free. You have to have discrete multi-slice pieces and low cost of integration. So what that means is, in Wikipedia, you can fix a spelling mistake, or you can fix an entire sentence. You can add an entire article, you can write a bot, those kinds of things. And your investment is up to you. You could spend 1 minute, 10 minutes, an hour there, and it has to be easy. You have to be able to go in and fix something without some sort of huge investment, which is why it's so nominally easy to edit Wikipedia, and it's why we try to make OpenStreetMap easier and easier to use over time. We haven't got that barrier entry down to nothing, which is why I'd prefer it to be. But we try to do these things. So, the analogy is that in OpenStreetMap, you can fix, your road, your neighborhood, or if you want to invest the time, you can import every river in the United States or something like that, which people have done. And so you've got these two things. One, John Boyd's OODA loops, which is suggesting merely by doing things quicker, you'll win. And then there's a bunch of economics behind it, which says that just by making this stuff open and available, you're going to be more efficient at producing this good than a market or a firm, which is, two of the ways I think about why OpenStreetMap is going to win. So let's talk about the map data marketplaces. It's similar to the first graphs that I showed you. So the x-axis is quality, and I put that in quotes. And then the y-axis is cost or price. I took quality in quotes because quality means different things to different people. So there's a couple of ways we could think about that. One is I could have a complete map of the United States, but from 1950, right? So it's very good, it's just out of date. Or I could have a complete map of California, but not the rest of the United States, right? So I'm restricting my geography. Or I could have a map of the US, but the whole thing is randomly shifted, which would be something like that public domain Tiger data, right? Or some combination of those three things. And then price is how much I charge for it. So here in the United States, you have this thing called Tiger, which is put out by the Census Bureau, which is of some nominal quality. So you saw that it wasn't great, that screenshot I showed you that improved in Oakland over time, but it is zero price. So it's on this line here. And what that allowed was people to take Tiger, this is what happened, and then improve it. So because they pushed it up the quality graph, they took that Tiger, they improved it the same way that OpenStreetMap did, except they paid people to do it. They were able to raise the price of those derived works because they're higher quality. So you can go pay for those things, right? In the European Union, things are very, very different. You should be a little bit careful whether I'm in Europe or European Union and so on. But let's just talk about Britain as an example. At the top right, you have a national mapping agency. So for example, in the UK, there's the Ordnance Survey. They're very well funded, and they also make very, very good maps in every way possible. So that means they're very, very high quality. They're all the way at the end of that line, but they're also very, very high price. High quality maps are typically very expensive because you have to pay for all those people, all those cars, all that gas to go drive around. And then there's OpenStreetMap. So OSM, over time, has improved in quality, but it started off somewhere here, right? So it wasn't completely awful, but it had to start somewhere. And it's zero price. We give it away for free. Now, there's a bunch of use cases that OSM was able to satisfy. So we couldn't give you a map of the whole world in 2008 or whatever it was for turn-by-turn navigation. But what we could do is we could give you a really great map of the Isle of Wight, as long as you didn't want house numbers, right? So there are use cases there. If you live in the Isle of Wight and you need something to print out on your wall, it works, right? As time goes on, OSM improves in quality, right? And as it moves up that quality graph, it's going to take more and more of the use cases away, right? And that's exactly what happened. And today we're sort of making this sort of quantum leap from display use cases over to consumer-facing turn-by-turn navigation. And so what that means is high quality, high price map data sets have to do something, right? They either have to come down in price, come down in quality, or both. In order to survive or innovate, go do something new. This is not something that's particularly new. We've seen this before with operating systems as an example, right? So when I started using Linux back in 1999, it was pretty awful. I mean, it actually still is pretty awful in many ways, but it was even more awful. I had to compile my own kernel. The display didn't work. You couldn't use a mouse and graphics. It was that awful. But it was still fun for an extremely poor student, living on noodles or whatever it was that I was doing at the time. So it was still useful for some things. And then there was Windows off at the top right somewhere, which was relatively speaking high price, but it was also much more high quality than Linux. You could install it and it would actually work as opposed to Linux, which required teams of engineers. As Linux swept up and got better and better, Windows had to do something. And you might remember that there was an awful lot of controversy that Linux was going to take over the world. We were going to all be using Linux on the desktop any day now. And that didn't really happen. And Windows didn't particularly come down in price or quality. It actually went up in both. But what they did do is they innovated, right? They went and did new things. So the operating system of 1999, say Windows 2000, is not different to it's very different to Windows 8.1 that you'd see today because there's a lot that's changed. The, web browsers are added, antivirus is added, all of the things are added into Windows that used to be add-ons and are just part of the core experience. So in terms of price per feature, things actually came down, right? Because you're paying approximately the same number of dollars, but it's doing many more features, so your price per feature came down, which is what we're going to see with proprietary mapping solutions. There has to be some innovation to compete with what OpenStreetMap is doing. So I'll sort of close by saying a couple of things. I really like what Airbus did to their aircraft. It was very bold. They painted their aircraft down the side. And I actually couldn't find a photo of the real aircraft that they did this for. I think everything got deleted or something. But they used to paint on the side of their aircraft, longer, larger, farther, higher, quieter, smoother. Thank you. And this is what they did with the A340-600, which at the time, which is the world's longest range airliner, amongst other things. And it's very bold to put that stuff out there, but it was also actually an in-joke, because if you open the door on the rear of the aircraft, this is what they did. Similarly, NASA had a very similar program where they revamped all their engineering to use off-the-shelf components, and instead of having very large top-down programs, they embraced a bunch of bottom-up management infrastructure and so on. And they did these faster, better, cheaper programs, which is what got us most of the recent Mars missions, right? And I think very similarly of OpenStreetMap, right? OpenStreetMap is just faster, better, and cheaper than everything else out there. And with that, that's my talk. So thank you very much for your time.